Hello all, welcome back to Techlearners. Let us continue the consistency test for the system of simultaneous linear equations. In the previous two lectures, we had already seen what are the cases for the consistency of system of simultaneous linear equations. There were three cases, and in the previous lecture, we had solved the first case where the system of equation was consistent with unique solution, and we had already solved it. So let's talk about the case number 2, where the system will be consistent but with many solutions. So let's take one example and solve it. Now let us see this example number 2, where we have system of linear equations. X plus y plus z is 6, x plus 2y plus 5z is 10, 2x plus 3y plus 6z is 16. To solve this, we will create the augmented matrix of this. So we will create the augmented matrix with the coefficients. This is 1, 1, 1 and 6. So 1, 1, 1 and 6. For the second row, this is 1, 2, 5 and 10. This is 1, 2, 5 and 10. Then we have 2, 3, 6 and 16. So this is 2, 3, 6 and 16. Now we will find out the rank of this augmented matrix by converting this into upper triangular matrix. So we have already done a video on upper triangular matrix as well as on rank of a matrix. You can go and watch that video, or we can solve this here as well. So let us continue solving this. Just to solve it, we will convert this into upper triangular matrix. For that, we need to identify the diagonal. So this is the diagonal. The elements with same indices 1, 1, first row, first column, 2, 2, second row, second column, and 3, 3, third row, third column. And below this, we need to convert all the elements as 0. So we need to convert this as 0, this as 0, and this as 0. So let us start doing this. Just to convert this as 0, we'll perform a simple row elementary operation. That is, R2 will be subtracted. Okay, so we'll subtract R1 from R2. So let me rewrite the matrix after the operation. The first row will remain same, 1, 1, 1 and 6. The second row, 1 minus 1, this is 0. 2 minus 1, this is 1. 5 minus 1, this is 4, and 10 minus 6, this is also 4. Okay, and I'll rewrite this 2, 3, 6 and 16. So this has been converted to 0. Now we need to convert this into 0, for which the operation would be, we'll subtract twice of R1 from R3. So the next operation would be R3 minus twice of R1. So I'll just rewrite this matrix after the operation. First row will remain same, this is 1, 1, 1 and 6. Second row will also remain same, this is 0, 1, 4 and 4. Now the changes will happen in the row number 3. So this is first of all 2 and 1. So we have 2 minus 2 into 1. 2 minus 2 into 1, which is 0. Then for this element, we have 3 minus 2 into 1. So 3 minus 2 into 1. Actually 3 minus 2, which is 1. For the next is, we have 6 minus 2 into 1. 6 minus 2 into 1, which is 6 minus 2, that is 4. And for the last one, we have 16 minus 2 into 6. So in this case, 16 minus 2 into 6. That is 6 2s are 12. 16 minus 12 is 4. So you can see this element is also converted into 0. Our next task is to convert this into 0. For that, we will perform the operation R3 gets converted by R3 minus R2. Simply, we will subtract from second row and this will become 0. So let me rewrite this after the operation. First row will remain same, 1, 1, 1 and 6. Second row will remain same, 0, 1, 4 and 4. Now the third row, 0 minus 0, this is 0. 1 minus 1, this is 0. 4 minus 4, this is also 0. And 4 minus 4, this is also 0. So we can see this is converted into upper triangular matrix, because below the diagonal all the elements are 0 now. So you can see this is C. Now what is the rank of C? Just to get the rank of C, we need to count non-zero rows. So you can see this is a non-zero row and this is a non-zero row, but the last row is a 0 row. So we have only 2 non-zero rows. Hence the rank of C comes to be 2. Now we'll extract matrix A from this. If we know this augmented matrix is created with adding this column, and this is matrix A. So we'll take first 3 columns to extract matrix A from this. So here matrix A after conversion would be 1, 1, 1, 0, 1, 4, 0, 0, 0. So this is the matrix A. We have already converted this into upper triangular matrix as well. And the rank of this matrix, let's find out. Now non-zero rows 1 and 2. So we can see third row is a 0 row. So again, the rank of A here also comes to be 2. So we can see rank of C is 2, rank of A is 2, but the number of unknown variables, which is 1, 2 and 3. So here we can say that what we get, the relation we get, rank of A is equal to rank of C, but this is less than number of unknown variables. As rank of A is 2, rank of C is also 2, which is less than number of variables, that is 3. So we have arrived to the second case where the system is consistent but with infinite solutions. In the previous example, we had already done consistent with unique solutions, but in this we can see that this system has infinite solutions. Now, let us solve and try to find out those infinite solutions by the same method. So, we will be using this augmented matrix and we'll find out the equations. So, from this augmented matrix, the first equation would be x plus y. So, this is x plus y plus z. This is equal to 6. So, this becomes the first equation. The second equation would be y plus 4z is 4. So, this is y plus 4z is equal to 4. And we will not have any third equation here. So, now we can see we have 3 unknown variables and we have 2 equations. In that case, 3 minus 2 is 1. So, we need to let one variable as some constant. So, we let z as t. So, we have let z as t and we will substitute this z into equation number 2. So, from that y will be equal to y plus 4t, this is 4. So, y is 4 minus 4t, we can say y is 4, 1 minus t. So, we have got the value of y in terms of t. Now, we replace this z and y back into the equation number 1 to get the value of x. So, now what is x? So, this is x plus, in place of y, we will have a 4 minus 4t. In place of z, we will have t and this is equal to 6. So, we can see that x is minus 4t plus t, which is a minus of 3t, we will send it on the right hand side, plus 4 we will send it on the right hand side. So, this is 6 minus 4 minus of 3t. So, x becomes 2 minus 3t. So, we can say here we have y, that is 4 minus 4t, we have x 2 minus 2t and we have z as t. Now, how we have got infinite solutions? We can substitute the values of t. Let's say if we put t as 1, then z would be 1, y would be 4 minus 4, 0, and z would be 2 minus 3, that is minus of 1. We can also write 2 as 2, t as 2. So, when t will be 2, z is 2, and similarly y will change and z will change. In this way, by changing the values of t, we can have infinite values of t. We can also have infinite combinations of x, y, and z. So, this is how we solve the system that is consistent and with infinite solutions. Now, what is the infinite solution? Z is t, y is 4 minus 4t, and x is 2 minus 3t. So, this is the case number 2. In the next lecture, we will talk about the case number 3, where the system is inconsistent and that has no solutions.